On December 27th, 2004, fishermen in the Arctic saw an aurora. No storm, no solar activity, no explanation they could find. What they were seeing was the aftereffect of a starquake on the surface of a neutron star 42,000 light-years away. In 0.2 seconds, that starquake released more energy than the sun will produce in the next 250,000 years. The burst crossed 42,000 light-years of space and changed Earth's ionosphere from night to day. Victoria Caspi of McGill University, one of the world's leading magnetar researchers, stated directly, "Magnetars are the only deep space objects to directly affect Earth. But what a magnetar actually is, and what it's capable of from distances that should make it irrelevant, is where this gets genuinely terrifying. A magnetar is a neutron star, the collapsed core of a massive star, compressed to a sphere no more than 20 kilometers across. The city of Karachi, the city of New York. That's the diameter. And inside that 20-kilometer sphere, the strongest magnetic field in the observable universe. 1 trillion times more powerful than Earth's magnetic field. 100 million times stronger than any magnet humans have ever built. At a distance of 1,000 kilometers, a magnetar's field distorts the electron clouds of every atom in your body. Your chemistry stops working. You don't burn. You don't freeze. Your atoms stop being atoms. But 1,000 kilometers is not the distance that matters most. The distance that matters is much, much further away. The average distance from Earth to the Moon is 384,400 kilometers, halfway to the Moon, 192,000 kilometers. A magnetar's field is strong enough to wipe the magnetic stripe of every credit card on Earth. Simultaneously, every bank card, every hotel key, every access card, from halfway to the Moon. That's not the lethal distance. That's not the ozone stripping distance. That's not the ionosphere disturbing distance. That is just the distance at which a magnetar's field erases information from objects on Earth's surface. The 2004 burst came from 42,000 light-years away. 1 light-year is approximately 9.46 trillion kilometers. The burst that changed our ionosphere came from 42,000 of those, and it still moved our atmosphere. To understand why, you need to understand what a starquake actually is, and what magnitude 32 means on a scale where the largest earthquake ever recorded on Earth was magnitude 9.5. The surface of a magnetar is not rock. It's a crystalline crust, neutron-dense matter so rigid that a starquake releases energy in a fundamentally different category from anything on Earth. The largest earthquake ever recorded, Chile, 1960, was magnitude 9.5. It killed thousands. It moved the Earth's axis. It triggered tsunamis across the Pacific. The December 27-2004 starquake on SGR 1806-20 was equivalent to magnitude 32. There is no frame of reference for magnitude 32. The Richter scale is logarithmic. Each whole number represents roughly 31 times more energy than the number before it. Magnitude 9.5 to magnitude 32 is not a comparison. It is a different category of event occurring in a different category of object, releasing energy on a scale that the human mind was not built to process. And in 0.2 seconds of that event, the energy that reached Earth changed the boundary between night and day in our upper atmosphere, from 42,000 light-years away. Here's what that means for anything closer. A magnetar burst within 10 light-years of Earth would be catastrophic, not disruptive. Not damaging, catastrophic. The burst from SGR 1806-20 came from 42,000 light-years away and disturbed Earth's ionosphere. A similar burst from 10 light-years away. The distance to Epsilon Eridani, a star visible in the night sky, would strip Earth's ozone layer. Not partially, not locally, globally. The same mechanism that governs GRB ozone depletion applies to magnetar giant flares. Gamma radiation breaks apart ozone molecules faster than they can reform. The result at 10 light-years is a planet-wide ozone collapse with no warning, because magnetar bursts, like gamma ray bursts, travel at the speed of light. The warning is the event. There are currently approximately 30 known magnetars in the Milky Way galaxy. Researchers believe the actual number may be significantly higher. Most magnetars are only detectable during active bursting periods. Between bursts, they are invisible. Now consider what the 2004 event actually did to Earth's instruments. The burst from SGR 1806-20 saturated every gamma ray detector in orbit. Every instrument designed to measure high-energy events from deep space, overwhelmed simultaneously by a single burst from the far side of the Milky Way. The initial spike was so intense that particle detectors normally used for completely different purposes on the Geotail spacecraft, on the cluster/double star mission, had to be used to reconstruct the event because the dedicated instruments were simply maxed out. The ionospheric disturbance was recorded simultaneously by stations across the entire globe. A 21.4 kHz signal originating in Hawaii, propagating to Palmer Station in Antarctica, a path of approximately 10,000 kilometers, showed the ionospheric signature of the magnetar burst at the exact moment of detection. A neutron star the size of a city on the far side of the galaxy disturbed a radio signal traveling from Hawaii to Antarctica, from 42,000 light years away. And magnetars don't just burst once. SGR 1806-20 had been gradually increasing in burst activity throughout 2003 and 2004. Its X-ray luminosity doubling in the year before the giant flare. The giant flare of December 27, 2004 was the culmination of that buildup. Magnetars cycle through periods of activity, bursting repeatedly, sometimes for months, and then going quiet. During quiet periods, they are undetectable, which means there are magnetars in the Milky Way right now that we cannot see, that may be building toward their next giant flare, and we have no way of knowing until the burst arrives, at the speed of light, with no warning. And the active life of a magnetar is only approximately 10,000 years, after which the magnetic field decays and the bursting stops, which means the magnetars most likely to produce giant flares are the youngest ones, and young magnetars are the hardest to detect between bursts. In January 2026, Science News Today published a detailed summary of magnetar research confirming that, as of 2020, magnetars remain the most powerful magnetic objects detected throughout the observable universe. No natural object has been found with a stronger magnetic field, and their formation mechanism means they can appear anywhere a massive star dies, which happens continuously throughout the Milky Way. Every massive star that ends its life as a core collapse supernova is a potential magnetar. The Milky Way produces approximately one supernova every 50 to 100 years. Not every one becomes a magnetar, but some do, which means magnetars are being born in our galaxy right now, some of them in our cosmic neighborhood. The question is not whether new magnetars are forming. The question is where, and whether any of them are oriented toward Earth, because a magnetar burst within 3 parsecs, approximately 10 light years, would severely affect the atmosphere and is associated with mass extinction scenarios in the academic literature. 3 parsecs. The nearest star system to Earth, Alpha Centauri, is 1.34 parsecs away. There are approximately 50 known star systems within 5 parsecs of Earth. None of them currently hosts a known magnetar, but magnetars between bursts are undetectable. We can only see the ones that are currently active, the ones that are quiet, the ones building toward their next flare. We cannot find until the burst arrives. And when it arrives, it travels at the speed of light. On December 27, 2004, fishermen in the Arctic saw an aurora with no explanation. The explanation was a neutron star 42,000 light years away. We still don't know how many magnetars are currently between bursts in our cosmic neighborhood. The only deep space objects that directly affect Earth are the ones we cannot see until they already have. Like if you'll never look at the night sky the same way. Subscribe to Star Dread, new cosmic horror documentary every day. Tag someone who thinks deep space threats need to be close to matter. What should terrify you next? Drop it in the comments.